Consider this word problem regarding vectors. Your friend skis 3 kilometers east and then 1.5 kilometers north. From this, it's clear we need a coordinate system. So I'm going to use the compass as a coordinate system. Like this. North, south, west, and east. I always remember how to put the west and east here because they spells the word we. Altogether, these compass points spells the word news. News. There you go. So using this as my coordinate system, we can solve this problem. And it says here, what is the total distance your friend skied? First thing we need to do is draw a little sketch about 3 kilometers east and 1.5 kilometers north. Now vectors are generally represented by arrows. So going east, going to the right, there's my vector going east, and it has a magnitude or a size of 3 kilometers, 3.00, and this will represent 3 kilometers. At this point, at the end of that trek, we're going to turn and go 1.5 kilometers north, 1.5 kilometers north. Now the thing about vectors, when you draw a scale or an arrow such as this one, they need to be a relative size. So the size of this one is about yay long. And I'm going to go north. And it needs to be about half that distance, so about here. Just to keep the relative size. And this will represent 1.5 kilometers, about half the distance of this vector. And it says, what is the total distance your friend skied? Well, he starts here, and he ends here. And the total distance that he has skied is going from here, going across all the way back up. So in part A, total distance is 3 kilometers plus 1.5 kilometers. And that's equal to, the units are the same, therefore we can add the two numbers up normally. And 3 plus 1.5 is equal to 4.5 kilometers. If we wanted to do significant figures, and for our course this is not required for addition. But if we want to do the significant figures here, we would add 3.00 plus 1.5. Add these up and we have 4.5. In order to do significant figures then, and this is a separate course, we would look here. And again, this is for a different course, and the answer would be 4.5 kilometers. That is the distance traveled going across. And for part B, it says here, draw a sketch to show how far your friend is from the starting point. So he started here, ended up there. The actual distance that he is, or how far he is from the starting point to the end point, is that distance here. So part B, I can simply redraw this portion. This is how far he is from the start to the end, or the finishing point. This vector here has a name. It is known as the resultant vector. Resultant displacement. The difference between distance and displacement is shown right here. Distance is from the start, going along the same path that the skier took. That would be distance, and displacement is the shortcut from where he started to where he finished. that shortcut right here, that has the name of displacement. And again, this distance across here is 3 kilometers. And the distance going up is 1.5 kilometers. So show the sketch or show how your friend how far your friend is from the starting point. And we did that here in introducing the word displacement. And sometimes this is resultant displacement. This is also sometimes written R with a vector arrow above it, representing the resultant displacement. And part C. What are the magnitude and direction of your friend's resultant displacement? That's this guy right here. So we want to find the magnitude, which is basically the length of this in terms of kilometers, and this angle. The magnitude and the direction with respect to the x-axis. What we have here basically is a triangle. So for part C, we're going to do the magnitude first, the size of this vector, the resultant vector, or the displacement. And since this is a triangle and everything here is at 90 degrees, that's at 90 degrees. For part C, I'll just simply redraw that here in a slightly smaller scale. This is 90 degrees. We want to find the resultant displacement, which is nothing more than the hypotenuse. If that's a right angle triangle, then this also has the name of hypotenuse. So we want to find the hypotenuse of a right angle triangle. We have some numbers, and I'm going to ignore the kilometers right now. I'll keep them in. 3.00 kilometers, and here is 1.5 kilometers. So we have the values of both lengths. All we need to do now is find the hypotenuse using Pythagorean theorem. Theorem for a right angle triangle. And that would be r squared. I'm going to call this r, the hypotenuse. R squared is equal to a squared plus b squared, if this is the length a and this is the length b. Putting in the actual numbers now for r squared, we don't know what r squared is. That's what we are looking for. The resultant is equal to a squared. Well, a can be this one or a can be that one. It really doesn't matter. So I've chosen this one. 3.00 kilometers, everything squared, plus 1.5 kilometers, everything squared. We need to remove the brackets. To remove the brackets, we have to use the squared here, and it operates on the number as well as the units. And that square operates on the numbers as well as the units in order to remove the brackets. So r squared, the resultant squared, is equal to 3 squared kilometers squared plus 1.5 squared kilometers squared. As before, since the units are the same, we can simply add the two values. So r squared then is equal to 3 squared is 9 plus 1.5 squared is 2.25 kilometers squared. Adding those two numbers together, r squared is equal to 11.25, and the units is kilometers squared. In order to reduce this down to simple r, we need to take the square root of both sides, take the square root of this, and the square root of the right-hand side. Whatever you do to the left, you have to do to the right. Taking the square root of r squared leaves us just simply r, which is what we are looking for, the magnitude of the resultant. And the square root of 11.25 is 3.354101966. And we also have to take the square root of kilometers squared, which is simply kilometers. Reducing this now to proper significant figures, the value of r is equal to, and as I said at prior videos, going back to the original word problem, looking at the measurements that were given to us, this one here is in 3 significant figures. This one is two significant figures. Therefore, the final answer for our resultant needs to be to two significant figures, 1 and 2. In order to round this, we look at the third one. If it's 5 or greater, we're going to round up. Less than 5, we round down. So this is 5, so we're going to round up. So it's approximately equal to 3.4, and the unit is kilometers. Just moving it over here. Therefore, the resultant displacement has a magnitude. Magnitude is a fancy word for size. Magnitude of approximately 3.4 kilometers. Now, part C also has another portion to it, and we need to find the direction. So we know the size of this vector right here, the displacement vector, resultant displacement, is 3.4 kilometers. And that makes sense. This length here is 3 kilometers, 1.5. This should be just a little bit greater than the 3. So that makes sense. Now we need to find this angle right here. Because vectors have both magnitude, here's the magnitude, and a direction. So we need to find the direction. I'm simply going to use another sheet. Here we go. To complete part C. C, find the direction of R. We'll quickly redraw the triangle. And this is 90 degrees. We know that this distance, we started here, that distance is 3.00 kilometers. And we know that that distance is 1.5 kilometers. And we calculated the displacement to be 3.4 kilometers. Now we know all three sides. We can use either sine, we can use cos, or we can use tan. Either one of these will work because we have all three sides and we want to find this angle right here. So I'm just going to simply use sine. Sine theta is equal to opposite divided by the hypotenuse. Putting in the numbers for opposite, here's the theta that I want. The opposite is 1.5. And the hypotenuse we calculated to be 3.4 kilometers. And kilometers cancel out. That leaves us with sine theta is equal to 1.5 divided by 3.4. Taking the inverse sine in order to isolate theta. Theta is equal to sine to the minus 1, the inverse sine of this argument, 1.5 divided by 3.4. Putting this value here in the calculator, theta then is equal to, using the inverse sine, or sine to the minus 1, is equal to 26.1789 degrees. Again, reducing this to proper significant figures, and we go back to the original question. Again, two significant figures. This is 3, so we have to go to 2. So the angle theta is approximately 26 degrees. But it's not just 26 degrees. We also have to give it some direction. So it's going north of east. This is east. That way is north, and we're sweeping north of east. So it's 26 degrees north of east. For part C, then, the answer is the resultant displacement is approximately 3.4 kilometers. And sometimes they use square brackets to give a direction, 26 degrees north of east.